Welcome to Creative World. In this video, we will solve Chapter 2 exercise problem number 2.97. While solving this problem, we will be using Kirchoff's current law. According to this law, a cumulative current on a node inside an electrical network is always equal to 0. Sum of all entering currents on a node is always equal to sum of all leaving currents from that node. We also will be using Kirchoff's voltage law. According to this law, a cumulative supplied and dropped voltage across circuit elements in a closed loop is always equal to 0. Ohm's law will also be utilized while solving this problem. According to this law, voltage across any resistance R is always equal to the product of current through it and the value of resistance itself. Now move towards the problem. Exercise problem number 2.97. Find the value of VA in given below figure, such that 5 ampere current source supplies power of 150 watt. This is the circuit diagram of given problem. Inside this network, we have to find the value of voltage across this voltage source labeled as VA. While one condition is provided in this scenario, power supplied through this 5 ampere current source is 150 watt. So without wasting time, let's proceed towards the solution. First of all, we will try to find out voltage across this constant current source because power supplied through this source is given. And we know that power is the product of voltage and current. If we know one quantity and power, we can calculate other quantity as well. In this case, the value of current is given, so we can calculate voltage using power conventional formula, that is the product of voltage and current. So using this equation, voltage will be equal to power divided by current. 150 watt divided by 5 ampere. It will become 30 volt. 30 volt will be appearing across this 5 ohm resistance, and the polarity of voltage will be positive terminal here and negative terminal here. In order to supply power through this 5 ampere current source, the current should leave from positive terminal. Modify the circuit by indicating voltage across this constant current source. Now this same current with the same direction will also be flowing from these two resistances because of series connection. So we can calculate voltage across these resistances. Voltage across this resistance will be the product of current through it and the value of resistance. It will become 10 volt. And the polarity notation of this voltage will be positive terminal here and negative terminal here because current entering terminal is taken with positive sign. Now the value of this resistance is also 2 ohm and same current is flowing through this resistance as well. So voltage across this resistance will also be 10 volt, but polarity notation will be opposite to this resistance. Modify the network by indicating voltage across these two resistances with their polarities. Polarity of voltage across this resistance is opposite to the polarity of this resistance, because through this resistance current is entering from this side and leaving from this side, but in case of this resistance current is entering from this side and leaving from this side. Now we will apply Kirchoff's voltage law inside this closed loop to calculate voltage across this 5 ohm resistance. For that purpose, we are assuming the direction of current in counterclockwise. Write KVL equation for this closed loop. Start from here, current entering terminal is positive, so voltage across this 5 ohm resistance will be taken with positive sign. Next, current entering terminal is positive, so 10 volt will be taken with positive sign. Next, current entering terminal is negative, so 30 volt will be taken with negative sign. Next, current entering terminal is positive, so 10 volt will be taken with positive sign. Now add these 10s together, their sum will be equal to 20 volt, and subtract 20 volt from minus 30 volt, it will become minus 10 volt. Place this minus 10 volt on the other hand side of equal to calculate voltage across this 5 ohm resistance, that will be equal to 10 volt. After calculating voltage across this resistance, we can calculate current through this resistance as well. Using Ohm's law, current equation will be I is equal to 10 volt divided by 5 ohm. So the value of current will be 2 ampere and the direction of current will be downward. Modify the network by indicating current through this branch with its polarity. Now we will apply Kirchoff's current law on this node to calculate current of this branch. On this node, one current is entering, that is 5 ampere, and one current is leaving, that is 2 ampere. So in order to justify Kirchoff's current law on this node, 3 ampere current should leave from this branch so that the accumulative current on this node remain 0. So 3 ampere current will be flowing from this branch and the direction of current will be right to left leaving from this node. Now we can calculate voltage across this 5 ohm resistance, that will be the product of 3 ampere and 5 ohm. It will become 15 volt and polarity notation of this 15 volt will be positive terminal here and negative terminal here. Modify the network by indicating voltage across this 5 ohm resistance with their polarity. Now in order to calculate voltage across this 4 ohm resistance, we will apply Kirchoff's voltage law inside this closed loop. For that purpose, we will assume the direction of current in counterclockwise. Start writing KVL equation for this closed loop. Start from here, current entering terminal is negative, so 25 volt will be taken with negative sign. Next, current entering terminal is positive, so voltage across 4 ohm resistance will be taken with positive sign. Next, current entering terminal is negative, so 10 volt will be taken with negative sign. And at the last, current entering terminal is positive, so 15 volt will be taken with positive sign. Now subtract 10 volt from 15 volt, it will become plus 5 volt. And add that plus 5 volt into minus 25 volt, the answer will be minus 20 volt. And place this minus 20 volt on the other hand side of equal to calculate voltage across 4 ohm resistance, that will be equal to 20 volt. After getting the value of voltage across this 4 ohm resistance, we can calculate current through this resistance, that will be equal to 20 volt divided by 4 ohm. So current through this branch will be equal to 5 ampere. And the direction of current will be downward. Modify the network by indicating current through this branch. Now we will apply Kirchoff's current law on this node to calculate the current of this branch. On this node, 3 ampere current is entering while 5 ampere current is leaving from this node. So in order to justify Kirchoff's current law on this node, current through this branch should enter towards this node. Let's assume current through this branch is I. So entering currents on this node will be current I and 3 ampere, while leaving current is 5 ampere only. Subtract 3 ampere from 5 ampere, it will become minus 2 ampere because larger value have minus sign along with it. And place that minus 2 ampere on the other hand side of equal to calculate the value of current I, that will become 2 ampere. So 2 ampere current will be entering towards this node from this branch. Now we can calculate voltage across this 15 ohm resistance because current through it is calculated. So voltage across this 15 ohm resistance will be the product of 2 ampere and 15 ohm. It will become 30 volt. 30 volt will be appearing across this 15 ohm resistance with positive sign here and negative sign here. Modify the network by indicating voltage along with its polarity across this 15 ohm resistance. Now we will apply Kirchoff's voltage law inside this closed loop to calculate voltage VA. Start writing KVL equation for this closed loop. Start from here, current entering terminal is negative, so VA will be taken with negative sign. Next, current entering terminal is positive, so 30 volt will be taken with positive sign. Next, current entering terminal is positive, so 20 volt will be taken with positive sign. Add 20 volt and 30 volt together, it will become 50 volt. and place minus VA on the other hand side of equal to calculate its value. So the value of VA will become 50 volt. This was exercise problem number 2.97. Thank you. See you again in next video.